Okay, this is a tale of how dynamic syntax, that's the framework we work in, emerged as a model of language as action. And as you'll see, and we're going to give it as an evolving narrative. This is me and Eleni, Gregoromichelaki. There are many people to thank for this, as will become obvious as we go on, and we're not going to itemize them now. Okay, so the first thing to say is that we think we are in a good position to accept the big hard challenge to linguists. And so I'm going to take you through that and then through what was the outset for dynamic syntax, and then a whole number of steps as to show you how, in fact, how the concept of grammar has changed really radically. And then when we get to step 7 in this list, which you've got in front of you at the moment, I will hand over to Eleni, who will take us through the final variant that's currently being worked on, which is the multimodal variant of dynamic syntax. Okay, so here is our taking up of the challenge. So most of you won't be very familiar with this, but linguists in general are not. So what we take as the big hard challenge to linguists is that the cognitive psychology and linguistics are quite 100 years out of date, and that we need to catch up with the lead of quantum physics, as indeed everyone else has been doing, because the code model of language of fixed rules assigning fixed values to strings, encodingism as he calls it, has to be abandoned. And it has to be replaced by explanations which have non-determinism, process and interaction as central and basic. And in this then, the new perspective is explaining cognition and its emergence I list here 6 things because these are things we're going to take up. And that is adaptation by differentiation and modal anticipation, interaction in context, because that's essential to adaptation, coordination relative to local context, representation and individuation being emergent, not primitives, and modeling the capacity to recognize and correct errors, because this is essential to learning and there's no inbuilt condition of mind reading. Not that one can't do it, but it's not necessary, not built in. Okay, so dynamic syntax, how does this meet the challenge, or to what extent does it? We have language as process. So for us, actions, coordination, and context dependency are central. We have modal anticipation driving coordination. We have incremental context dependent, indeed moment by moment update. We define concepts of locality in terms of growth. We have interaction as an immediate consequence of our action perspective. We can express error recognition and correction, and we have no essential mind reading for underpinning interaction. And on these 6, we'll add as a final thing before I hand over to Eleni, the challenge of capturing lexical content as non-deterministic. Okay, so here's the outset. What we set out as the beginning was indeed to model the interpretation process for relevance theory. So I was working as a straightforward linguist, and I saw that we had to provide them with a model of interpretation since none of them were actually doing that. So I took on the initial goal of what came to be called dynamic syntax was pragmatic. That's under specification and update were assumed to be at its core, and that is sustained. And for that I turned to Dov Gabay, who has defined the concept of label type deduction. We took this as the model of input and enrichment. And because of this, in LDS, labels express the constraints on content and indeed procedural constraints on the proof steps, so that the types can remain relatively low. Now, when we came to the formal specification, we came across Wilfried Meyer-Viol, who was working on the epsilon calculus. And when he came to us as a postdoc, he brought the wonderful, wonderful bonus of having worked with Simon Blackburn on the logic of finite trees. So he could define for us a framework which combined a label deductive system using the epsilon calculus and using LOFT, as we call it, the logic of finite trees. So the revised objective was indeed to model incrementally a goal-driven process of constructing tree representations of content. And we had indeed a dynamic model of LF construction process. And these formal things remain at the heart of it. But the first surprise we got was solving syntactic semantic puzzles. And that made us realize that we were on the cusp of having to argue for a really radically new concept of natural language grammar. Now, the reason for this was because just look at the puzzles that we could explain. We found ourselves naturally having completely natural explanations of what were taken by other people to be puzzles in virtue of reflecting the dynamics of how interpretation is incrementally built up. I'm not going to give you them all, but you can see there were many word order effects, left, right, asymmetries, and so on. Though historical and very cosmologists, in particular, Heraclitic clustering, these very weak pronouns, which are very stipulatory in individual languages. And there were also puzzles for semanticists And in all these cases, what had to be presented as the solutions involved positing multiple ambiguity and ad hoc construction-specific stipulations. And in all these cases, we thought we could offer natural solutions. So we took it that the old style syntax has to be jettisoned, just abandoned. So we're giving up the notion of grammar as a sentence structure inhabited by words. We're giving up an encapsulated domain specificity syntax. And indeed, we're giving up the competence performance distinction because we're replacing those by grammar-defined actions used by speaker and hearer, of which these actions drive word-by-word update of structure and information, and it's always relative to an ever-changing context. Now, the second surprise that we got, which I shall be taking you through, is the fact that we got a direct explanation of dialogue exchange interactivity. This is the sole data for language acquiring children, but it's actually inexpressible in all conventional frameworks. So let's take, first of all, the utterances. So I always like to throw in a family example. So this could be this is in fact a constructed example, the second one is not, of my daughter-in-law, who could say, we're going to, she can never remember where my sister lives. So Hugh, the father, butts in and says, to Burbage, to see Anne, Auntie Anne. To which Elliot adds on, with the dogs, Hugh says, if you take care of them. Now, this is a conditional sentence, the antecedent and the consequent, but it's simply not anticipated by anybody with a sense of overall planning. And this is a very common pattern amongst in dialogue modeling. Now, the real challenge for linguists comes from this, that you can get this switching of roles between agents across every single morphosyntactic and semantic dependency that any linguist has tried to understand. I mean, just anyone. So here's one of my favorite examples where I say, I'm afraid I burned the kitchen ceiling, to which Michael, my husband, might reply, did you burn? And I would chip in and say myself, well, no, fortunately, not only my hair. Now that's an anaphor, which its antecedent is given by my husband. That reflexive pronoun myself is given by me. And there's actually a switch of morphology here in order to reflect the change of speaker. But there's also WH gap dependency. These were the canonical evidence for movement. And the WH right at the left periphery of a sentence has to be seen as somewhere far embedded in the clause. But here we can split it across two individuals perfectly easily. And notice that the choice of words that B chooses has to match the morphological requirement of what A has set him up with. Then you can play the same game across island constraints. So islands were things which linguists say you cannot move out of. So there were these types of construction which in some sense preclude being disrupted in any way, moved into, moved out of. But in fact, again, these can be very naturally split across people. Then there's quantifier variable dependency. Again, you can one person can set up the quantifier and somebody else can provide the thing that's dependent on that quantifier. And it's notable that in the example of 6, that A can't just treat what B says as an interruption, because if she puts her two parts together, you'll come out with an ungrammatical sentence. So it's crucial that we're always building on the context given by the other person. And very natural pedagogical ones are determiner noun dependency being able to be split between individuals. And notice that this is true for small children. So small children, nursery rhymes very characteristically have this. So old MacDonald had a farm, on that farm he had a, and the child has to say cow. So that's not the end of the problems. The problems are also semantic, that there's no specific proposition that has to be intended. No specific goal or speech act is needed for communicative success. The only thing that's absolutely essential is interaction. So the example 9 is given as an example from the BNC, British National Corpus, where in fact in the second sentence, which A starts to interrupts immediately after the utterance of those first two words, the doctor, children. And so there's no way in which the intended second proposition, which A is supposed to be trying to say, is being presented for him. And there may not even be a fully determined proposition anticipated, as indeed when people come up to me on the Strand in Covent Garden, I don't even know what language they naturally control, they can say to me Covent Garden, and I simply reply right at the lights and straight on up. I haven't produced a single verb, but that doesn't interfere with anything. Now, the content and the intentions may develop through dialogue interaction because you can interrupt what other people say, if you're in argument, let's say, and simply continue in the way that you think ought to be said. So it's obvious from what you say, second person takes up that you're wrong. Now, even speech acts can evolve via interaction, as in the example of 12. And again, notice this is characteristically available for small children too. So a nursery teacher can say, and your name is some kind of a question to which the child responds with something which provides the answer. Okay, so what do the dialogue data really show us about language? Well, what they show is that clarifications, corrections, role switches in dialogue, they're all fluent core data because they all function to optimize interaction. They're absolutely not a performance disfluency. Rather, both utterance understanding and utterance planning, as indeed is what now well recognized in the literature, are incremental. So we have to see dialogue processing as a highly coordinated sub-propositional activity, because structure, content, context, intention, speech acts, they all mutate and evolve. And mind reading really is not a prerequisite for successful communication. It's not diagnostic of what communication has to be in order to be successful. And indeed, language acquisition emerges through interaction. That's also very well known in the literature now. Okay, so now I'm going to take you through a bit of our model. So this is language as incremental context relative processing. And the sense of syntax, insofar as we have it, is the top-down, partially bottom-up building LF structure. So you're going to be looking at these tree representations. On this slide, there are actually two trees. There's the tree on the end, which is the result of processing who lost Ray, but there's also the tree on the left-hand side, which just says T node TN0, tree node 0, and a requirement for type T. So the one on the left is the point of departure, the one on the right is the result. And this is all goal-driven, context-dependent actions for parsing and production, which are used in either inducing or linearizing content and word sequences. So in all these, all you need to know is that the tree node 0 is the root node, so that's the point of departure. In all these cases, we're going to say that noun phrases, or DP, that's what I should probably call them, they're type E epsilon terms, following Wilfrid's lead. Now, what we have here is lose, which is a two-place relation, but here we've made it three-place because these are semantic structures and we're going to be building an event term reflecting the tense. So we have lose as a three-place relation, which, and there's two arguments, internal arguments to it, Ray, who's the object, and the WH, which is a placeholder for where the answer has to be provided. And these are binary branching trees, and they're defined by loft, that's the modal tree logic of Wilfrid. And now let's see what this is. There's the logic of finite trees. This is the heart of what this system turns on. So it's a very simple modal logic, which is defined by, you can, from any point in a tree node n, you can define what holds at your daughter. That's the down arrow. And we differentiate two of these, one for an argument daughter, down of me, holds an argument daughter, or you can say down of me at one node holds a functor daughter. But you can also do the inverse. So you can, from a point, you can look up a node in the tree and say, well, X holds at my mother. But also one can define Kleene star characterization. So one can define a notion of dominate. So one can talk about X being dominated by tree node N. So tree node looking down star X is tree node dominates X. Somewhere below is X. And the inverse, somewhere above me is X, is the last of these. Now for this, we want to get a notion of growth. So the tree logic has to have added to it a concept of growth. And we get these through what we call requirements. And that is, for any decoration on the node of a tree can always have a requirement. And these are what correspond to underspecifications. They are requirements anticipating updates. Now, the very familiar ones from the literature are underspecifications of content, let's say for anaphora, pronouns, and such like. And for these, we assume that they are of type E, and they have an associated metavariable placeholder. And notice the requirement. There's a requirement that there be a fixed formula value. And WH words, we in fact think for questions, are a specialized type of metavariable. But more of interest from the point of view of the syntax is that we assume that there's an underspecification of structure replacing movement. And this isn't just that the nodes need to be more developed. It's we want to characterize some nodes as actually unfixed, as having a relation to some node above them, which is not yet fixed. Now, so we can see these. Now, the point of these is that the notions of trees are really epiphenomenal here. It's actions all the way. There's no assumption of fixed trees hanging around in the ether. We have to build them. And we assume that there are computational, lexical actions and general actions and computational actions. They're conditional. They're defined in a tree building language. So what I'm giving you here is two, which you really don't need to look at the stuff on the right-hand edge. It's just to make you see visually that this is all in the same language. So we can have rules which allow us the license of building one of these unfixed nodes, merely characterized by the concept of dominate, as an early construction step. And we can also characterize words such as verbs, inducing a whole propositional structure. And now, rather than wading through those, I'm going to take you immediately to how these combine. So we see interplay between lexical and tree development actions at any step. So the earliest step might indeed be building one of these unfixed nodes, decorating it in virtue of processing who with a specialized meta variable for questions, characterized as merely within this structure somewhere without that yet being resolved. And then along comes the processing of lost, which will induces the whole structure it needs to reflect its adicity. And then once having done that, it fixes the interpretation, this being English, it fixes the WH term on this unfixed node. It fixes it as unifying with the subject, and then places the pointer at the object position. That's the little red thing telling you where one's got to in the process. So the overall statement is that the action language induces the building of underspecified formula decorations, underspecified relations in the trees, and then assigns and compiles these decorations. And it's all triggered by requirements imposing constraints on update. In other words, anticipations. Now, in fact, when we come to the more complex structures of relative clauses and coordination, we take this simple view of assuming that we're always building these predicate argument structures, but they can be incrementally projected as quasi-independent, what we call linked trees, simply sharing an itemized common term. Now that is really a talk for another time, but nevertheless, we now move on to the fact that this is a grammar formalism. So because it's a grammar formalism, we have to characterize what are all possible transitions. And we have what we call an interaction control state, sometimes called a DAG, direct acyclic graph. Because what this graph is showing you, it's modeling possible parsing generation states and how they unfold and how some of them are atrophied and die, and at least one of them gets through. So the words are the partial trees, the nodes in this tree, the nodes in this diagram are nodes in a partial tree. The licensed actions are the edges, and the words are the higher level edges over the triggered actions. And you can see here, there's two possibilities initially. You could either have an adjunct, but who is not an adjunct, so that one aborts. We could build one of these unfixed nodes, and that is indeed duly decorated by who. Having decorated to, again, we could introduce an adjunct structure, but given lost, that also aborts. So we have the means of opening up and closing off actions displayed in this kind of demonstration. So what it is that the word triggers are doing, they're ensuring access to affordances for action provided by the immediate environment. And indeed, words and affixes, they all guide adjustment of actions. They indicate corrections and boundaries, etc., making transitions also an affordance. And indeed, we can capture in the need of corrections, we can capture this via repair by allowing local backtracking to the first compatible point in the path. Now, this was for me a major move, because I thought, this is what computationists do for one, to define an implementation. But it's when we assume that this is part of the core that we really have the full characterization of being able to model correction and repair. Okay, so now let's see it against real data in context. And this was the first very simple one, is that the split utterances that we talked about, they just fall into our lap, because it's the very nature of interstructure building in context which enables the interaction. So as a grammar, the actions are underpinning both speech and understanding. There's continual predictions of upcoming input and incremental licensing, which can lead to somebody taking over and assuming you go. So here is my starting to say, I've lost, and Hugh, turns out that's my other son, will say keys, and look at what we've got in the diagram. This is the shared context at the shift. Very common pattern of activity in our house that I lose my keys all the time. So this is a very, very well-known situation, which is under description. But in providing the words I've lost, I as the speaker, I have induced that structure of lose as a free place relation with two arguments and an event term. And uttering those words, Hugh at the point of takeover, he himself has also built exactly this structure because he knows the language. He knows that lose induces this kind of a structure. So it's entirely natural for him to take over at this point and provide the completion. So what is the phenomenon of this is that the process of uttering or comprehending both generate differentiation of further common action affordances. So both parties are following the same construction process. And the result is we're getting interaction across whatever structures directly achieved without mind reading, even speech act shift. Okay, now here's the other test. The other test was, as a perfectly ordinary bona fide linguist, I thought if this is to be competitive for other linguists as a replacement of syntax, we ought to have something which would show us this. And the question was whether we had a new answer to putative syntactic universals. Now, there is a constraint which appears to be observable, that it appears to be the case that one of these unfixed nodes at a left periphery, you can only have one of them at a type at a time. That's what it looks like. So in English, you can't say 15 at all. But now, as a possible counterexample, the verb final languages are very obvious putative counterexamples because the NPs can occur in any order, but they can't be assigned position until the verb is processed. Now, 16 is Japanese. The object, the subject, and the dative can be in any order whatsoever. It's just that the verb has to come finally. But our resolution is that, look, case suffixes here, they're inducing the necessary immediate updating of an initially locally unfixed node to the position the suffix locally determines. So you have this pattern of building an unfixed node and then resolving, building an unfixed node and resolving it. So that's in fact compatible with the constraint. But there's then a further puzzle associated in these languages, which is very broadly displayed in such languages, that actually you can get more than one of these at the left periphery. So now look at 17. We've got the document to the spy. Those are right out of the left periphery. And then what the sentence is actually saying is, the police reported that the journalist gave the document to the spy, but the document to the spy has been moved right out to the left. But there is a very tight restriction here, and that is that any paired fronted NPs, they must be resolved within the same local domain. And again, we have a very natural explanation, because on our story, you can indeed build an unfixed node as a platform, but then as a differentiated subcase of unfixed nodes, we can build locally unfixed nodes. So there's nothing to stop you building a platform from that platform introduced, building yourself locally unfixed nodes suitably updated by the case system. So the puzzle about multiple long distance dependency is resolved. Now there's an additional twist to that, which was really very pleasing, that we're getting confirmation from morphosyntax. And that is that, if, for example, in Romance languages, they have these preverbal clitic clusters, which seem incredibly stipulatory. There are simply clitic sequences, and the ones which are particularly precluded are ones which underspecify their construal. So you can't say in French 19. Now, the pattern of free word order languages displaying rigid agreement ordering is very widespread. But the explanation is that what we're getting here is a diachronic freezing, interweaving what were structural and pragmatic options in the source language, as in, for example, Latin, which also displayed exactly the same pattern as I gave you in the Japanese case. And then via routinization, these get stored lexically as lexically defined clusters, and they simply preclude the sequences which never occurred. So that's why you get these weird gaps. So the remains of this supposed universal constraint is actually a very secure functional underpinning. There is no reiteration of building an unfixed node. It's an intrinsic constraint. That was because all tree construction processes are non-trivial updates. So in principle, reiteration of one and the same transition without further differentiation is impossible. Okay, so here's the final thing which really has begun to obsess me in just recent months. We must have a semantics for which has an undetermined perspective. That's because polysemy is just everywhere in natural languages, really everywhere, everywhere, everywhere. Just look at the two cases of burn. You can burn your fingers, you can burn your back if you don't use sun cream, you can burn your hair, you can burn the house, you can burn the Amazon forest. These are all very different effects for burning. And also lose, but yeah, I mean, there are just too many of them. All languages display them everywhere. So we're trying to address this challenge with the procedural semantics of vector space semantics, where the starting point is to assume a vector as a pointer plus direction across multi-dimensions. Now, for most of you, this is really very familiar. The distributional semantics is a way of looking at saying that the meanings of words are captured statistically, simply by assessing similarities between words from vast datasets. But the DS construal is that actually gathering collocations from vast datasets is a working analog for modeling words as public resources, triggering selected sets of affordances from within the vast array of affordances available to agents. And so we're assuming that words are assigned a vector, and these can then be composed by a number of operations. Now, I'm not going to take you into the details of this because the work is really very preliminary, but it is worth stressing before handing over to Eleni that it's really very important, because otherwise we're not saying anything about semantic content. But if we can capture the non-determinants of semantic content, then we'll be doing very well, because it ensures fluent dialogue exchange despite mismatching in individual abilities. Having non-determinism of content allows us to shift affordances within individual speaker or individual exchanges. It gives, through the word, stability across such varying affordances, and that in its turn allows for effective group creation without requiring action content. And that rounds out the view of language as a tool for building and guiding shifting affordances for interaction. And that takes us a very long way along the cutoff from encodingism. And now I hand over to Eleni, who's going to give us a multimodal variant of this grammar.
So DS has various versions depending on the type of semantics it is paired with. We now turn to a version of DS that colleagues and I have been developing recently. DSTTR is a grammar architecture that attempts to implement the view that the basic ontology of language is processual rather than representational. These processes are domain general, not specific to language, so they extend seamlessly to multimodal interaction, either interaction with the environment or interaction with other participants in the conversation. So incrementality, specificity, and predictivity are properties of the grammar itself, like in dynamic syntax. And according to standard DS, interactions are all that you need to talk about syntax in natural languages. So standard syntactic representations assumed in standard frameworks are taken to be epiphenomenal. There is no phrase structure level of analysis, and sequences of words are analyzed as sequences of affordance triggers. Grammatical affordances can then be taken as a formalization of the notion of unfolding practices. So as regards the semantics that we pair with this grammar, the semantics and pragmatics, DSTTR, in my version at least, is underpinned by the theory of types in TTR, with reconceptualization of TTR as types of affordances, as types being affordances. So in that conception, types or concepts are dynamic, time-extended processes constraining how an agent can interact with its social environment or, in fact, its material environment. Standard TTR types are time-extended processes, and the know-how of types in a culture allows hierarchically or hierarchically, as I call it, structured predictions regarding courses of action, or as we call them, policies, which are available to groups of agents. And these policies now function as practices with normative force. So, but this means that multiple affordances will be available at each moment. And even though a particular course of action needs to be selected at all times, the rest of the available affordances will remain in the background as available options. So the unit of analysis for the definition of the syntactic mechanisms and conceptualization now is a distributed cognitive system encompassing interacting agents and their environment. Simplifying a bit, the set of opportunities for action available to the agents is called the landscape of affordances, and joint action is enabled on the basis of collective affordances in a particular situation. This replaces the representational notion of propositional common ground in the literature, and it is parallel to the notion of situation conventions in Marx's work. Given the incremental nature of the architecture, the landscape of available affordances or situation conventions is transformed with every action or event at every time step. So interactions in this framework constitute the basis for syntax, semantics, and pragmatics. And it is joint action that is being modeled, hence interleaving comprehension and production processes are part of the modeling rather than relying on the abstraction of a neutral grammar between comprehension and production. Now, the formal definition of the STTR, syntax and semantics in that formalism are defined as transitions from states to states. This is underpinned by a specialized version of propositional dynamic logic. And this is important for our purposes because such logics have been used to model any type of physical or mental action, and therefore multimodality in interaction is captured naturally in these terms. Now I'm going to show you a simplified illustration of the changing landscape of affordances as it unfolds for the participants during the selection, planning, and execution of an utterance. An utterance, let's say, Flopsy, which is the name of a rabbit, which is salient in the background. So Flopsy here is used to refer to the rabbit, the salient entity. And as you can see, there are various affordances in the background that the agents could have taken, but have chosen to instead perform a verbal action, namely the action of referring to the rabbit by the term Flopsy. And here we go. This action then opens up a landscape of further available affordances. A selection has to be made there again. The red route, the red arrows show you the selections that have been made from the available affordances in the landscape of affordances. So from the various options available to the participants, selection of a joint course of action is determined by the joint contingent facts prevailing in the context. However, other available affordances, even though in the background, they remain as live options updated incrementally at each time step and enabling the agents to switch seamlessly among themselves and among various multimodal actions. So, what do we have here? We come to the conclusions. So in the STTR, we have a holistic view of grammar as guiding production or characterizing comprehension behaviors. And this relies on a distributed knowledge basis of sensory motor contingencies on the part of the participants, and without any need for necessary construction of internal models of the world. The incremental and predictive architecture allows the integration of verbal action with physical action and perception. And on this basis, symbolic and other representations can be seen as externalist and emergent. Moreover, combined with vector space models of lexical semantics, as Ruth was showing earlier, this view can be construed as an implementation of exemplar theories of conceptualization, but instead of having them as brain internal storage, we can build them on an externalist basis. And here is now our concluding remarks regarding the general DS architecture and what we take to be the evidence that corroborate, the interdisciplinary evidence that corroborate our perspective. So we have evidence from language acquisition and development that interaction is there from the beginning and forms the basis for subsequent subsequent emergence of other social skills like verbal action and conceptualization. We have evidence from neuroscience and philosophical analysis of interaction, which provide the basis for shifting the focus away from internal processes towards the externalized normativity of sociality and collective affordances. And finally, we have Marx's interactivism, which provides a general, fine-grained and well-thought-out model full of inspirational ideas and challenges to be implemented in any architecture that has claims in modeling cognition and social processes. We would like now to mention a few points of discussion that we would like to pursue as a dialogue between DS and Marx interactivism. DS has been framed as a distributed cognition framework rather than assuming the fundamentality of the autonomy of agency. However, both interactivism and DS have been inspired by the Gibson's ecological psychology, so a lot of common ground should be found here. From that perspective, then, there are parallels between DS and interactivism, perhaps modulo the more externalist DS orientation. For example, there is a focus on the fundamental status of processes rather than static entities. And there is the assumption that representational notions or encodicism can emerge for basic action substrata. In terms of formalization, dynamic syntax is a constraint-based framework so that it exhibits parallels with the implicit definitions background of Marx's model. This has desirable consequences for both, in that we get avoidance of the various so-called frame problems, and we get a plausible generalized variation and selection method for problem solving and epistemology. Moreover, we also seem to agree in taking utterances or verbal action as operators on fields of affordances rather than encodings with representational contents. We also attribute a lot of significance on the fundamental nature of language as being anticipatory or predictive. We also attribute action selection and agent motivation basically to emotional states and values rather than rational choices and mind reading capacities. And these assumptions lead in the domain of linguistics to assuming domain general processes to ground the phenomena, rejecting the fractionation of the field into distinct subdisciplines. Now, perhaps a more unclear point is whether, like DS, Marx assumes that the basic notion here is coordination of processes rather than communication. This is something that we would like to clarify. But now, given the distributed cognition orientation of DS, this might generate questions when seen from Marx's interactivist perspective. For example, an interactivist might ask, if cognition is distributed, as you say, how do you account for phenomena whose explanation needs to overcome so-called epistemic boundaries? Our answer to this is that we reject the notion of a hard, permanent epistemic boundary between an organism's internal processes and the world, and this includes human cognition. We believe that this notion of epistemic boundary is an artifact and remnant of representational and substance assumptions and attended methodological choices to always generalize to the worst case based on, for example, phenomena like illusion in perception. In processual frameworks, we believe we have enough resources to account for coordination rather than communication or epistemological coincidence without these foundational internalist re-representations that presuppose some kind of epistemic boundaries for their resolution. But then the interactivist might ask, how do you then get learning and adaptivity of agents? And our answer will be a standard answer in ecological psychology involving processes of the education of attention following training and skill development within social practices. And more generally, by relying on the progressive appropriate structuring of an agent's environment, namely the ecological niche, due to evolutionary and societal cultural processes. So this is our contribution, we hope, of interest to the interactivists, and we will hope that we have this chance to discuss these issues at the live meeting at the conference. Thank you for attention. Thank you for your attention.